Hello, the question says that two blocks to the same metal having same mass at temperature T1 and T2 respectively are brought in contact with each other and allowed to attain thermal equilibrium at constant pressure. So the change in entropy delta S for the process is. So we need to find change in entropy delta S for the process. So let's solve this question. So from energy conservation, initial energy is equal to final energy. So we can write U initial is equal to U final. So initial energy of first block will be N1 CV T1. Initial energy of second block will be N2 CV T2. And final energy of both the blocks will be N1 plus N2 CV TF. So TF is our final temperature. So now in the question we have given that the two blocks are same, so therefore N will be same. So we can write NCV T1 plus NCV T2 is equal to 2NCV TF. So now we can cut N and CV. So now we got TF is equal to T1 plus T2 divided by 2. So now at constant pressure, delta S is equal to Cp ln T2 by T1. So change in entropy of first block delta S1 is equal to Cp ln Tf by T1, and change in entropy of second block is equal to delta S2, which is equal to Cp ln Tf by T2. So now total change in entropy delta S is equal to delta S1 plus delta S2. So delta S1 is equal to Cp ln Tf by T1, and delta S2 is equal to Cp ln Tf by T2. So now let's take Cp as common. So we got ln Tf square by T1 T2. So now we have calculated Tf is equal to T1 plus T2 by 2. So therefore delta S is equal to Cp ln T1 plus T2 by 2 square divided by T1 T2. So finally delta S is equal to Cp ln T1 plus T2 whole square divided by 4 T1 T2. So this is our delta S. So now let's match all the options. So our fourth option is our correct answer. Cp ln T1 plus T2 whole square divided by 4 T1 T2. Thank you.
Hello. So question is saying this, the process with negative entropy change is, right? So we have to find out in the following process we have to find out which has a negative entropy change, right? So which have a negative entropy change. That means we have to calculate delta S is equals to negative, right? So delta S is equals to negative, right? So as we know that entropy is the measurement of the randomness, right? And we know that for the solid, liquid and gas has a highest entropy as compared to solid and liquid, right? So that means I can write here that is solid has a less entropy, after this liquid has a high entropy, and gas has a highest entropy, right? So gas has a highest entropy, right? So this is the main thing, right? Because in the case of gas, the randomness is more, right? So now if we talk about the option A, right? So if we talk about the option A, so you can see here the option is dissociation of calcium sulfate to calcium oxide and sulfur trioxide, right? So you can see here this is calcium sulfate, right? So this is calcium sulfate, right? And this calcium sulfate is in solid state, right? So this calcium sulfate is in solid state, right? Now when this is dissociated into calcium oxide, right? So when this is dissociating into calcium oxide, right? So that is also in solid state, and sulfur trioxide, right? So you can say this is also in gaseous state, right? So now you can easily see this, the entropy change, that means delta S here, right? The delta S here comes out to be positive, right? So because there is a gas here, right? So from if you want to find out that, you can, if you just subtract it, so you will see this, there is a more gaseous state, right? Gaseous state is in product side, right? So that means product has a high entropy as compared to reactant, right? So in this case, if you can say the higher minus lower number will give a positive value, that means the entropy change will be positive here, right? So entropy change will be positive here, right? In this particular case, right? So now, if we talk about the option B, right? So if we talk about the option B is saying this, you can say the sublimation of dry ice, right? Sublimation of dry ice. Dry ice actually is a CO2, right? So now CO2 is actually which is in solid state, right? So this is our dry ice, right? Solid state, right? So when it sublimate, right? So it will go into gaseous state, right? So it will go into gaseous state, right? So you can see here, gaseous state has a high entropy as compared to solid state. That means this also will give the value of delta S, which is equals to positive value, right? So which is also equal to positive value, right? So this means that delta, in this case, delta S has a positive value, right? So now if we talk about the option C, right? If we talk about the option C, so you can see here, option C, dissolution of iodine in water, right? So option C is talking about dissolution of iodine, right? So iodine is actually in a molecular state, that is a solid state, right? So when it is dissociated, when it is, or you can say this, when this is added into water, so let's say when we have water added in it, right? So that means there is a aqueous solution of iodine, right? So aqueous solution of iodine, right? So let's say this is iodine, I2, right? So now you can see here, in this particular case, this is our liquid state, right? So this is our liquid state and this is our solid state, right? So from here you can see that the liquid has a high entropy as compared to solid, right? So in this particular case, the delta S, right? So the delta S comes out to be positive, right? So because higher number minus lower number will give a positive value, right? So in this particular case, we will have a positive delta, that means positive change, right? So that is positive change, right? So now finally we have the one more number, that is, you can see here, that is synthesis of ammonia from N2 and H2, right? So if you talk about the option D, you can see here, in this particular case, when we carry out the synthesis of ammonia with nitrogen and 3 mole of hydrogen, so we will give the reaction, that is 2 mole of ammonia, right? So 2 mole of ammonia. All these are in gaseous state, right? So all these are in gaseous state, right? This is also in gaseous state, right? And this is also in gaseous state, right? So you can write down here, right? So you can write down, this is also in gaseous state, hydrogen and nitrogen also in gas state, right? So now you can see here, in this particular case, there are 2 mole of ammonia, right? So, and there are 4 mole of reactant, right? So 1 mole for nitrogen and 3 mole of hydrogen, right? So that means we'll give the value here, that is 2 minus 4, that comes out to be here the delta S change, the entropy, you can say the delta Ng, the change in the number of moles, right? So delta Ng comes out to be 2 minus 4, that comes out to be minus 2, right? So you can see here the delta H, right? So the number of moles comes out to be here, change of the number of moles comes out to be minus 2, right? So that means entropy is going to here decrease, right? So that means entropy change, right? So the entropy change comes here negative, right? So comes here negative, right? So in this way you can see this is the only answer that has a negative entropy change, right? So you can see here in all the option we have, here it is positive value, here it is positive value, here it is positive value, but in this particular case the synthesis of ammonia has a negative entropy. That's why ammonia is a, you can see there, it can be formed from nitrogen and hydrogen at a very high temperature and pressure condition, right? So in this case this entropy change becomes negative, right? So now you can see here, so in this way you can see the option D will be the right answer, right? Option D will be the right answer, right? Option D will be the right answer, right? And rest of the option becomes wrong, right? A, B and C becomes the wrong answer, right? So hope this answered your question. So thank you.
क्वेश्चन है, हमें इसमें गिवन है, कह रहा है कि एक आइडियल गैस है अंडरगोज आइसोथर्मल कंप्रेशन। आइसोथर्मल का मतलब क्या हो गया कि यहाँ पे जो आपका चेंज इन टेम्परेचर है वो क्या हो चुका है, यहाँ पे आपका टेम्परेचर चेंज क्या है आपका 0, मतलब dt आपका 0 है और आपको पता है कांस्टेंट टेम्परेचर पे जो आपकी इंटरनल एनर्जी होती है आइसोथर्मल में du आपका क्या हो जाता है, 0 हो जाता है। तो जो आपका फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स है उसके अकॉर्डिंग डेल्टा U इज इक्वल टू Q माइनस W। इंटरनल एनर्जी आपकी 0 हो गई तो Q क्या हो जाएगा आपका W के इक्वल, ठीक है। अब देखिए आगे हमें क्वेश्चन में क्या गिवन है, कह रहे हैं कि जो आपका कंप्रेशन है वो 5 मीटर क्यूब से 1 मीटर क्यूब हो रहा है अगेंस्ट अ कांस्टेंट एक्सटर्नल प्रेशर ऑफ इतना, आपका जो प्रेशर है वो इतना है। तो मतलब वॉल्यूम की अगर बात की जाए, आपका जो डेल्टा V वो कितना हो गया 4 मीटर क्यूब, चेंज की बात कर रहे हैं। और यहाँ से जो आपका प्रेशर है वो आ गया 4 न्यूटन पर मीटर स्क्वायर। देन नेक्स्ट कह रहे हैं हीट released in this process is used to increase the temperature of 1 mole of aluminium. जो हीट इस प्रोसेस से रिलीज होगी हम उसको टेम्परेचर इंक्रीज करने के लिए यूज करेंगे 1 मोल एल्यूमिनियम का. कह रहा है इफ मोलर हीट कैपेसिटी ऑफ एल्यूमिनियम इज 24, अगर जो मोलर हीट कैपेसिटी है दैट इज सीपी. सीपी आपका कितना है 24 जूल पर मोल पर केल्विन. ये आपका इतना है. द टेम्परेचर ऑफ जो एल्यूमिनियम का टेम्परेचर है वो कितना इंक्रीज होगा आपको वो बताना है हमें. ठीक है. अब देखिए आपका जो Cp है ये किस चीज के इक्वल होता है. Cp होता है आपका Q इक्वल्स टू Cp dt. ठीक है. अब हमें Q नहीं पता तो Q हम यहाँ से निकाल लेंगे. Q इक्वल्स टू W और W होता है आपका PdV. यहाँ पे प्रेशर हमें गिवन है 4 और जो आपका वॉल्यूम है उसका चेंज भी 4 है. तो यहाँ से हीट कितनी आ गई आपकी 16. जो ये आपकी 16 हीट आई है इसको हम यहाँ पे पुट करेंगे तो हीट हो गई 16. जो आपकी Cp है वो है 24 और आपको dt चेंज इन टेम्परेचर तो आपको कैलकुलेट ही करना है राइट. तो यहाँ पे आपका जो dt है वो आ जाएगा 16 डिवाइडेड बाय 24. तो ये आ रहा है आपका 2/3 केल्विन. अब ऑप्शंस में देखें तो देखिए जो आपका C ऑप्शन है ये हमारे आंसर से मैच कर रहा है जो कि इसका राइट आंसर है.